welcome. Let us look at sequences and series. Because I don't want to waste a lot of time, I have written some few notes here which I want to share with you. A sequence is a pattern of numbers in a definite order. That a sequence should have an order. There must be a rule leading or governing that sequence. So let us look at this sequence 5. At least the first one is 1, 5, 9, 13, 17, and then continuous. So this is an example of a sequence. This is an example of a sequence. So a sequence is made up of terms. So these numbers you are seeing here that forms a sequence, each number is called a term. So this one, number 1 is the first term. This one is the second term. This is the third term. 13 is the fourth term. 17 is the 1, 2, 3, 4, 5, the fifth term. Very nice. For a pattern to form a sequence, it must be governed by a rule that is consistent in our For example, in our sequence here, the rule, what was added to 1 to form 5, you can see very clear it is 4. So add 4. If you add 4 to 1, the answer is 5. Add 4 to 5, the answer is 9. Add 4 to 9, the answer is 13. So the rule is you add what? Add 4, and that gives us. So this 4, how do we obtain 4? 4 is 5 minus 1, the answer is 4. 9 minus 5, the answer is 4. So 4 is called the common difference. 4 is called the common difference. Very good. So I want to take you now through to the two types of series that we have. Before I take you to the types of series that the sequences that we have, the position of a term in a sequence is represented by n. The position. For example, in our sequence 1, 5, 9, 13, 17, next is 21, the first term is position 1. This is the term and this is the position. So the first term is position 1. The second term, which is 5, is in position 2. Then third term is in position 3. The fourth, 4, position 4, position 5, like that. So if you are asked the position gives us the what? The n of that sequence. For example, the fourth term in our sequence is represented by 4. That is 1, 2, 3, 4. That is the fourth. So n for the fourth term is 4. I hope you have gotten that. So when given the n gives us the term, the position of the term in a sequence. It gives us the position of a term in a sequence. Very important to note. There are two types of sequences: arithmetic sequence and geometric sequence. So we will begin with arithmetic sequence. In arithmetic sequence, this is a sequence in which consecutive terms, now you know what a term is. I said this is a term, the second term, third term, in which consecutive terms differ by a fixed value called a common difference. We give it small d. So, for example, in this sequence 1, 5, 9, 13, 17, so we need to know by which value is the consecutive term differing from the other one, from the preceding or the previous. So to do that, the second minus the first one. So 5 minus 1 will give us 4. And this 4 is what we call D. D is the common difference. So the common difference here, D is equal to 4. Even if you subtract 13 minus 9, the answer is going to be 4. 9 minus 5, the answer is going to be 4. It is fixed. So for arithmetic sequence, we use a common difference, that is 4. So in this case, the first term, we write it, first term is given by letter A. In arithmetic sequence, the first term is given by A. So if it is given by A, and then the common difference, we have said it is 4. Now, how do we get the second term? Second term, so if I want to get the second one, what do? It is 1 plus 4. So let me use, if the first term is A, then the second one is going to be A plus D. What is D? The common difference. To get 5, it is 1 plus 4. And what is 4? D. So if I use letters, I will say A plus D will give me the second term. So the second term is given by A plus D. The third term, you can see it is A plus D, which is 4. That's 1 plus 4. And then plus 4 will give me the third term. You are seeing that? 1 plus 4 gives me 5. 5 plus 4 gives me 9. In other words, I'm saying A plus D plus D. So this one is the first term, plus D gives us the second term, plus another D gives us the third term. So in short, we are going to say that A plus 2D is represents the third term. The fourth term is represented by what? A plus 4, which is the D, plus D plus another D. That makes it 13. 1 plus 4, 5. 5 plus 4, 9. 9 plus 4, 13. So that one is A plus 3D. So you realize that if I am on the fourth term, the formula for the fourth term is the D is 1 less the fourth. So A plus 3D, the fourth. So if we want now to predict the 10th term, will be automatically be A plus, this is 10, you minus 1, that is 9D. It will be A plus 9D. That will be the formula. Therefore, generally, the nth term is given by A, the first term, plus N, which is the position, minus 1 times D. So this is the general formula for an arithmetic sequence. That is the general formula for an arithmetic sequence. Examples. Find the 20th term in the arithmetic sequence below. Find the 20th term. So solution. First, you need to identify A, you identify D, and then N. Remember, N is the position of the term. So the position of this term is 20, therefore N is 20. D is the common difference, so 7 minus 4, that is 3. 10 minus 7, the common difference is 3. A is the first term. The first term is 4. And then now we know the formula A plus N minus 1 times D, the common difference. The first term is 4 plus N is 20 minus 1 times 3. So that one will be 4 plus into 19 times 3. So 19 times 3 is 51. Is it 51 read or 57? So let us see. 19 times 3, 27. 2. That is 5, 57. So it is 4 plus 57. And this one gives us 61. Right? Find the number of terms in the arithmetic sequence below. So we have been given a sequence 4, 7, 13, and then the sequence continues, and then at the end, the last term is 61. So first write A, D, and N. So it is asking the number of terms. And I told you the number of terms is represented by n. The number of terms stands for n. So here we are looking for n. D is going to be 3. A is going to be 4. The first term is 4. The common difference is 3. 7 minus 4. So now we apply the formula. A plus n minus 1 times D. We are looking for D, but this one, it will give us the last, which is 61. So A plus n minus 1 times D, which is, so instead now let us substitute, this is 4, and the D is 3. The answer is 61. So 4 plus this times this, 3n minus 3, the answer is 61. Like terms together, this is 3n is equal to 61 minus 4 plus 3. Then 3n is equal to 60. Divided by 3, divided by 3. N is equal to 20. So the number of terms in this series, for it to go to 61, it will contain 20 terms. It will contain 20 terms. You can do it manually and you will realize, because we are adding 3, 3. Can you add 3, 3 and then you find it, you reach 60? Count how many terms will they be. They will be exactly 20. So that's what it means. The second and fourth terms of an arithmetic sequence are 6 and 12 respectively. Find the first term and the common difference. Find the first term and the common difference. So in our solution, the second term will always be A plus D, and this one will be equal to 6. The fourth term, you subtract 1, so it's going to be A plus 3D will be equal to 12. So you realize you have now a simultaneous equation. Then you need to find the value of A and D. This one is simple. You use elimination method. Eliminate A. So if we eliminate A, we are going to remain with negative 2. D will be equal to negative 6. And we are going to divide it by negative 2, divided by negative 2, and our D is going to be 3. Our D is going to be 3. Then now substitute to get the value of A. So A plus D, which is 3, is equal to 6. So A is equal to 6 minus 3. A is equal to 3. Remember, A is the first term. We have answered that, and D is the common difference. So that is how you solve this one. As simple as that. An employee has a starting salary of shilling 10,000 and an annual increment of Kenya shillings 2,500. Find the salary at the end of the 50th year. So this is the application of arithmetic sequence. So you see, this employee has a starting salary. So the starting is our A because the first is A. And then the annual increment, because it is increasing annually, and it is this one, so that is going to be our D. And then our N is going to be 5. 5 is going to be our N, the 50th year. So once you have identified that, A equal to 10,000, N equal to 5, D equal to 25. Now you substitute in the formula and you get that 10,000 plus 5 minus 1 times, this is N, times D, which is 25. So that one is 10,000 plus 10,000. At the end of the 50th year, she will be earning 20,000 Kenya shillings. You can as well try manually, and you will realize that it is correct, very correct. Geometric sequence. A geometric sequence is one in which the consecutive terms have a common ratio. For geometric sequence, we have a common ratio. For example, in my sequence here, 2, 6, 18, 54, 162. So this one is the first term, second term, third term. That is fine. This one is the term, the position that represents N. So this is position 1, 2, 3, 4, 5. So this 162, the 50th term is represented by N is equal to 5. I have said that. Now, how do we get the common ratio? The common ratio is obtained by dividing the second term by the first one. Divide the first term by the second, the first term by the second. Divide the second term by the third one, like this. So R is obtained by either 6 divided by 2 or 18 divided by 6. The answer is going to be 3. So how do you get R? Ya pili una divide by ya kwanza. Ya tatu una divide by ya pili. Ya nne una divide by ya tatu. Ya tano una divide by ya nne, unapata R, which is the common ratio. Usifanye opposite. Don't divide 2 divided by 6. No. It should be the second by the first, the third divided by the second, the fourth divided by the third, like that. Now that one gives us the common ratio. So the first term always remains A. So the first term is going to be A. So I want us to do something here. So if the first term is A, so we have 2, 6, 18, 54, 162. I have said this one is the first term A. 2 is equal to A. What can we do with the ratio to get this one? We multiply. So A, which is 2, times 3, we get 6, which is the second term. 6 times 3, which is the ratio, gives us 18. 18 times 3 gives us 54. And 54 times 3 gives us 162. So what you can see clearly that the first term A times R gives us the second term. So first term, second term, third term, fourth term. So I've said the first term is always A. So if I want the second, what do I do? The first term is 2. 2, for me to get 6 is 2 times R, which is the radius, the common ratio. 2 times 3, which is the common ratio, will give me 6. So this one is A times R, will give me the second one. How will I get the third one? It is 2A times R times R. So this one is going to be A. R times R, it's going to be R square. To get the fourth term, it is A, the first term, R cube. So you realize that the next term has got radius less 1. So if I want now the 8th term, I can predict it is going to be A, R minus, that is 8 minus 1, which is going to be 7. So now the nth term for a geometric sequence is going to be A, R, N is the position, then minus 1. And this is the general formula for a geometric sequence. The general formula for geometric sequence is A, R, N minus 1, where N is equal to the position of the term. For example, if I want the formula for the 15th term, it means N is equal to 15. So I will simply say it is A, R for 15 minus 1, and this one is going to be A, R 14. A, R 14 is the 15th term. Determine the 6th term in a geometric sequence below 1, 4, 16, and this. So in our solution, first identify N, identify A, identify R, which is our common ratio. For geometric sequence, we use R and not D. D is used in arithmetic sequence. So our N is the 6th, that is the position of the term that is required. 6th, so here is 6. A is always the first term, 1. R, it is 4 divided by 1, or 16 divided by 4, and that one is going to be 4. So now you apply the formula A, R, N minus 1. So our A is 1 times R, which is 4, raised to power 6 minus 1. And this is 1 times 4 raised to power 5. And this one gives us 1024. That is the 6th term will contain that. The 5th and the 8th term of a geometric sequence are 6 and 48 respectively. Find the first term and the common ratio in this sequence. So the fifth equal to A, R to power 4. You subtract 1 from N. And this one will equal to 6. And then the 8th will be A, R raised to power 7. You subtract 1. And that one will be equal to 48. So we know how to get the common ratio. It is the bigger divided by the small. So A, R raised to power 7, you divide by A, R raised to power 4 will be equal to 48 divided by 6. So you can cancel what is cancelable, and then this one is R raised to power 7 minus 4. You remember indices, how to do this? Or you can as well write 1 times R times R times R up to 7. times r, 1, 2, 3, 4, 5, 6, 7, and then r times r times r times r. So if you cancel 4 of them, we are going to remain with r3 is equal to 48 divided by 6 is going to be 8. So you realize that our r, you find the cube root both sides, is going to be cube root of 8. And r is equal to 2. So we want now a. For us to get a, you can take r and substitute either in this equation or this one. So a, r raised to power 4 is equal to 6. So a, 2, which is r raised to power 4, the answer is 6. 2 raised to power 4 is what? Is 16. So that is 16a is equal to 6. Divided by 16, divided by 16. So a equal to 3 over 8.